These images you're seeing are from the first public test of a crash between two fully electric Mercedes cars. This is a very rare event to witness, since they intentionally crashed two electric cars. Unlike what you usually see in these kinds of tests, which is a collision between two internal combustion cars or an electric car crashing into a fixed obstacle. But why did Mercedes conduct and make this test public? What was learned from it? And why are the cars involved in the test painted in this orange color? Well, ever since cars became more and more common and an extremely important item for traveling long distances, their safety started to be taken very seriously. In this way, tests began to be carried out in order to understand whether each model developed was safe and capable of keeping its occupants protected. In the event of an accident, which could be a collision with another car or with some physical obstacle. Over the years, several organizations have been created, focused solely on conducting crash tests between vehicles. To better understand these events' dynamics, as I discussed in a video on the channel. However, until now, most of the data obtained in these tests are from internal combustion vehicles, that is, vehicles powered by fossil fuels, such as gasoline and diesel. The structure of these vehicles is significantly stronger and more resistant because they have an engine and several engine components in the front part of the vehicle, which is where the collision occurs. However, in recent times, a new category of vehicles has become popular, which are electric vehicles. These are vehicles powered by electricity, which is stored in batteries. In the floor of the vehicle, with the vehicle having practically nothing in the front part, where the engine would normally be located. Therefore, the dynamic behavior of an internal combustion vehicle during a collision and the dynamic behavior of an electric vehicle also during a collision would be completely different. But actually, no. Both behave in a very similar way. That's because both are designed so that their front structure gradually deforms as it absorbs the energy from the impact, which is very important and safeguards the lives of the occupants. However, the problem is that in internal combustion cars, the fuel tank is located at the rear of the vehicle. A very well thought out location that greatly reduces the chances of an explosion or fire during or after a collision. And what about electric cars? The battery sits centrally beneath the vehicle's floor, taking up the entire middle section. This can be potentially dangerous, since any dent or puncture in the battery can cause a short circuit and start a major fire directly in the area where the vehicle's occupants are. And it was exactly this point, among several others, that Mercedes aimed to understand much better by conducting this test. The test preparation started long before and involved dozens of professionals from various fields, including accident specialists, engineers and damage specialists, electrical and electronic engineers, among many other professionals. They started by simulating the collision in various software programs, which are quite reliable, which help the team to better plan the event and discuss technical details. Next, two electric cars from the brand were chosen. In this case, a Mercedes-Benz EQA, which has a range of 490 kilometers, and a Mercedes-Benz EQS, which is an SUV with a range that exceeds 550 kilometers. Both were taken directly from the assembly line. The next step was to paint the vehicles orange. But why orange? Well, during the test, some cameras that record the event film in black and white, and the color orange has a higher contrast in these images. Once chosen and painted, dozens of pieces of equipment are placed on board, which will record hundreds of parameters, from the correct deployment of the airbags to the tire pressure. And an important component in this test are the dummies, which are ultra-sensitive devices used to measure human injuries in car accidents. Basically, they will record all kinds of movements and impacts against objects or surfaces in a way that is very similar to how a human being would. They are so sensitive and so technologically advanced that some of them can cost up to $1 million. With everything ready, it was time to crash the cars. The test was done with both vehicles moving at 56 km/h, and the collision occurred with only 50% of the front part of both vehicles. That's because in real life, many times, one of the vehicles always ends up partially swerving away from the other. Second, due to the impact, this causes the accident to only occur in about 50% of the front part of the vehicles. Right after the collision, it was, to some extent, dangerous to approach the vehicles, since there was an electric smell in the air, coolant leakage from the batteries of both vehicles, and it was not certain whether the high-voltage battery systems of the cars had automatically disconnected, as expected. But after quick analyses, it was proven that everything was fine and it was safe to approach the cars. The full results obtained from the test have not yet been released by Mercedes. All the material is still being analyzed, but it is known that in an accident involving electric cars, the vehicles behave in almost exactly the same way as in an accident involving regular internal combustion cars. The deformations and the overall level of damage are practically identical. That's because the design of today's cars is already planned so that the cars are safe before, during, and after a collision. It's also important to emphasize that the test was done with two cars of different sizes: the Mercedes-Benz EQS, an SUV, and the other a sedan. And the weight difference between them is around 771 kilograms. That's why the Mercedes EQA ended up being more damaged, even having its tire completely torn off. One fact already mentioned by Mercedes is that none of the dummies suffered a fracture that could be considered fatal, which shows that today's cars are safer than ever. Another observation made by the analysis team is that it is necessary to add more layers of protection for the car batteries. Not that they aren't currently safe and they have an automatic system that shuts off the high voltage system in case of an accident. However, due to their location, which is right below the occupant's feet, if the impact is strong enough to dent the car's floor, a short circuit and a subsequent fire are still a significant possibility.